Okay, so thank you, Diego. What do you do if you're working with heritage software for control of an experiment and you lose the only person that supports that software? You ask around to see if there's anybody capable of taking it on. And somebody pointed me at RSE at that point and said, talk to Diego. I did, and Diego introduced me to Alex Dewar, Dan Cummins, and James Turner. And between the three of them and ourselves, we've taken that GUI interface software and are expanding it on to that initial experiment and further experiments. So I want to do science, and the science that we're looking at is atmospheric physics and the way that the atmosphere modulates the outgoing long-wave energy and cools the planet, so it's interaction between the surface and the atmosphere itself. We had a couple of different experiments. We first initially called RSE to help us with finesse, which is this experiment here. It's fairly simple in nature. It's a spectrometer that covers the mid and far infrared, sits on the ground. We use a commercial spectrometer to do the measurements of the spectrum. We have our own front-end calibration and viewing system to allow us to look at various different angles in the atmosphere and at the surface, looking at emissivity. This is typically deployed to Arctic regions, and we get out spectra that look rather like this. More recently, we have a new airborne system, UNIRAS, which has been funded by the UK and ESA, and this will be flying on the UK research aircraft FAM. And what we really need is a versatile graphical user interface, which will interface and link with the hardware and software for the whole of the system, provide system real-time control, display system environmental data, and monitor and log system environment variables so that we can do a lot of processing. And this is where FROG, the Far Infrared Observation GUI, comes in, and it's a graphical user interface which replaces our original data set. It was very useful having these guys on board. So this is it's a lightning talk, so it's other than giving an overview of what our initial requirements were, and the predicament we were in, and were helped out by RSE. This is just a screen capture of the graphical user interface. What we see here at the top is this allows us to, with this particular interface, to link in with either Finesse or with UNIRAS. We can then design viewing, automated viewing cycles for how we want to set up the experiment and then leave it running. We have an interface with the spectrometers, which are ones, as I said, was commercial, ones custom built by a commercial company, so that we can interface with those instruments and get their health and status reports, as well as control them from this interface. We can, the system is designed so we can also have instrument simulators as part of this system. So it allows us, it's quite powerful in that respect. It allows us to do a lot of testing without the physical presence of some of the instruments, which is a really useful system to have on this. With the other thing that they're helping us with, James Turner has been looking at the aircraft ancillary information. They had their own local area network, so this system will be linking into that to provide real-time core data from the aircraft as well. And then this section here allows us to configure our calibration targets and gives us monitoring of the system states there as well. Right, so I want to just finish with what we learned. So initially based, our control system was initially based on legacy C# code. It's not a solution for the long term. FROG is written in open source Python. Finesse and UNIRAS experiments are expected to have lifetimes of 20+ years. And so we'd like to have everything written in a language which will be supported for long term. And RSC have committed to that, I think. What we find is that they're experienced, competent, and motivated software engineers with a mix of backgrounds, which Diego alluded to, hardware, software, and science. I find that they listen to what I want and deliver what I need, which might not necessarily be the case, the same. We have full system version control and redundancy against loss of experienced personnel, on-site problem solving and support, which has been really critical, and support for modification and expansion of the system. Hence, we've been able to extend this to the second experiment that we're interested in flying in the future. And I think that's it.